This is part 2 of section 5.4 in factoring trinomials. Now, when we have the highest power in the trinomial is higher than a 2, and the exponent in the middle term is half of that of the other term, we could introduce a substitution to help us factor it, such as here. For x to the 8th power minus x to the 4th minus 6, and we are going to let u be equal to x to the 4th. Before applying that substitution, quick note: this x to the 8th, excuse me, we could see this is the same thing as x to the 4th squared, since raising a power to a power multiplies the powers. So 4 times 2 would make 8, which allows us to then use this substitution I have here. So if we let u be x to the 4th, this would just be a u squared, because of what we have here, minus u minus 6. And that does factor nicely. With a 3 and a 2. With the 3 negative and the 2 positive. So u minus 3 times u plus 2. And then at the end, just replace that substitution. This would be x to the 4th minus 3 times x to the 4th plus 2. So factoring these trinomials, x to the 4th minus x squared minus 6, we would just need to let u be x squared. So this trinomial becomes u squared minus u minus 6. And it factors actually just like that last one on the last slide, with a 3 and a 2. A negative 3 and a positive 2. So u minus 3 times u plus 2. And replacing the substitution that we did, this will be x squared minus 3 times x squared plus 2. And for this bottom one, x to the 6th plus 7x cubed minus 8. Again, we could substitute, let u be x cubed. So this would be u squared plus 7u minus 8. And that does factor. And the factorization that we could use is 8 and 1. A positive 8 and a negative 1. So u plus 8 times u minus 1. And putting back in that substitution, this would be x cubed plus 8 times x cubed minus 1. So factoring a trinomial like 5x squared minus 14x plus 8 does have that 5 in front. We can't factor anything out. So if we have a trinomial in that form of ax squared plus bx plus c, where a is not 1, the first 2 terms are factors of a, the last 2 terms are factors of c, and we need some combination to make b. And if no such combination exists, the trinomial is again considered prime over that set of integers. So another method of factoring ax squared plus bx plus c, if that first method was on the more difficult side, would be by grouping. We would multiply a and c, determine the factors of a and c that make b, and then rewrite b as the sum or difference of those factors, and then finally factor by grouping. So to first show then what we just had on the last slide, let's do that factorization first. The factors of 5 are 5 and 1. Factors of 8 can be 8 and 1 and 2 and 4. And the only other factor that pairs with 5 and 1 to make this particular trinomial and add up to be negative 14 is going to be 2 and 4. If we multiply 5 and 2 and 4 and 1. So the factorization of that would be 5x. Since we want to multiply the 5 by 2, and we want this to be negative, this would be a negative 4 times x minus 2. And if we want to get the same result, but with the factoring method I currently have here on the screen, let me just quickly erase this so we can see that. We multiply the a and the c, so that makes 40. We want the factors that add or subtract to make 14. That would be 10 and 4. So this can be rewritten as 5x squared. We would have a minus 10x minus 4x plus 8. And now we could factor involving that by taking our greatest common factor of these first two terms and of these last two. So for 5x squared minus 10x, we could take out a 5x times x minus 2 minus, we could take out a 4 and have x minus 2. And since both of these are the same, which they better be, otherwise we can't do this, we have 5x minus 4 times x minus 2 again as that complete factorization. So now factoring these trinomials, we have 12x squared plus 11x minus 56. So the factor pairs that we have for this, we have many. 12 and 1, 4 and 3, 6 and 2, and of course, flipped as well. We have 56 and 1, 7 and 8, 4 and 14, 2 and 28. A lot of them. The ones that will work for this, though, are going to be 4 and 3 for 12. And for 56, that's going to be 7 and 8. So let's start plugging in. Let's put the 4x here, 3x here. In order to get the 11, we want to multiply 8 and 4 and 7 and 3. So 8 will go here, 7 here. This is negative. The last term is negative. The middle term is positive, which means we want the 8 to be positive, since that'll be, we'll multiply by 4, 32, the biggest. And 7 and 3 multiply us to make 21. So we want that one to be negative. 4x minus 7 times 3x plus 8. For the bottom one, 5x squared plus 8x plus 3. Well, we only have two factors for 5 and 3, so this one is a lot nicer. 1 and 5 for 5, so 5x and x, respectively. We do not want to multiply the 5 and the 3, so the 3 will go here, and a 1 will go here, due to 3 and 1 being factors of 3. And we want both of these to be positive, since 8 is positive, and so is 3. Let me know if you have any questions or concerns. Thank you.